Hello, fifth graders. I hope that you are staying safe. I hope that you are enjoying your break. I know that I was excited for my break. I know that we all needed this break. I think I'm at the point where I think it's been long enough. I am ready to get back in the classroom. I'm ready to see you all. I miss you all so much. I am excited for when we can get back together, but for right now, we are doing the best that we can by learning virtually, getting some practice in, preparing for our learning when we come back, and even taking some time to review things that we already know. I am going to do this video not for support, but I am going to try my best to do a little bit of new teaching today. Just like I always ask of you, I want you to try your best. Did you try? Did you give your effort? We are not perfect, and it is really hard for me to think that you are going to be the best you can be through a computer. But I think everyone can try and everyone can give their effort, and when we get back into class, we will have a little bit of a head start on our new learning. So this is not the best situation. It's not what I would prefer to do, but we are going to push through. We're going to persevere. We are strong. We are capable. We are so smart. So I know you all can do it. Today, I am going to work on the learning targets on the screen. I can add fractions. Adding fractions is something that we learned in fourth grade. And we are going to continue our learning to the next level in fifth grade, because remember, math is something that continuously builds, and everything that we learn, we're going to build from that. So today we are going to look at adding fractions. What do we know about adding fractions, and what are some things that we can do to continue that learning? So when I think about adding fractions, and I will tell you all, I am struggling with being able or teaching in this manner, because you know that I like for us to discuss things and have these discussions, discover things together, explore in math class. Today I'm going to be doing a little bit of telling, which is not my favorite thing, but I'm talking to a computer screen right now. So we're all doing the best we can. It says I can add fractions. When I think about adding fractions, and I'm going to tell you this, when we add fractions, the denominators need to be the same. So 1/2 plus 5/9. And actually, let's start with a different example. 1/2 plus 2/3. And I think this was an example that was on our video from yesterday. So 1/2 plus 2/3. I can add those fractions, but the denominators are not the same. So I'm going to show you, and I hope this does not mess up my show, but I'm going to show you that problem on my screen right now. So I said 1/2 plus 2/3. So if I was to get out my pieces, 1/2 plus 2/3. I can put them together. I can add them and talk about those pieces. Like one, I'm always going to say like half a pizza plus 2/3 of a pizza. But right now, I'm looking at those pizzas split into different size parts, a half and thirds. And so I'm still looking at two different pieces or size pieces of something. I'm going to use the example of like if I had 2 apples plus 3 bananas. If I put them in a bowl, I can put them together, but you are still seeing that the parts are different. Like you will see the 2 apples and you will see the 3 bananas. So fractions are the same thing. Like when the denominators are not the same, you can see that these are put together. This is solvable, but right now we're not seeing what those pieces mean in relationship with each other because they are put in different portions or different size pieces. So I'm hoping that okay, so let's go back to this. When we add fractions, the denominators need to be the same. We need to add apples to apples and oranges to oranges. We need to add halves to halves and thirds to thirds so that we can see our sum in the same size or in the same thing, right? Even though I said that they have to be the same, and 1/2 and 2/3 has a half and a third, the denominators are 2 and 3, we can do this. And the way you do it is by finding a common denominator. And what a common denominator is when the denominators are like denominators, when the denominators are the same. We're going to go over some examples today of looking at different fractions to add and seeing if we can add them the way they are. Do we need to find that common denominator? Do we need to make the denominators the same? And what are some of the ways that we can do that? Before we get started, I want you to take a deep breath. Put our hands on our head. Let it out. Think about the things that you can do and the things that you do know. Put your hands on your shoulders. Take that deep breath in and let it out. And lastly, let's put our hands on our knees and know that we are going to persevere. When things get hard, we push through. Take that deep breath in and let it out. Hands on our head, shoulders, knees. Clap 2 times. Let's get started. I am going to be switching back from this screen to the other one so that we can look at those fraction tiles again, because I think it is so important for us to see the fractions, the visual models. I say it all the time. I like to see visually, learn visually. I want you all to be able to see things in different ways as well. I'm going to be using those pizza examples because I did order pizza this week and I'm super hungry all the time. But let's look at this problem. Remember, when we add fractions, the denominators need to be the same. So the first problem we look at is 5/7 plus 4/7. 5/7 plus 4/7. The first thing I want you to ask yourself when we are looking at fractions that are added or subtracted, are the denominators the same? In 4th grade, when we were talking about this with tenths and hundreds, we would say, do we have the green light? Are the denominators the same? Green light, can we go? Green light means go, we're ready to solve this problem. So when I'm doing that, I'm going to say, are our denominators the same? Looking at my denominators, 7, 7, those match. I am adding sevenths to sevenths, they are the same. Apples to apples, they're the same. I'm ready to go, I have a green light. So, oh no. Okay, so I'm going to go to the next slide. To add the following fractions, do you need to change one, both, or neither of the denominators, and why? So when I looked at this, I said, okay, look at the denominators. 7 and 7, they're the same. I don't need to change them. I have the green light to go. I can add these fractions. So I'm going to see what I can do here. Ooh, look at me, this is fancy. It said, so I'm going to say to solve this problem, I do not need to change the denominators. I know this because they are already the same. So I don't need to change a denominator. They're already the same. I'm ready to go. It says if the denominator was changed, what would be the common denominator? Well, I did not mean to do that. I'm learning, you all. So if the denominator was changed, what would be the common denominator? Well, the denominator wasn't changed. I'm going to go ahead and put a 7 in there. Okay? I don't need to change it. It's a 7. I'm ready to go. When we add denominators, we're going to do denominator stays the same. These are going to be sevenths. I have 5 parts, 5 out of 7, 5 parts of the 7, plus 4 of the 7. 5 plus 4, both of them are 7s, is 9. My sum is 9/7. Stop. 9/7. Fraction is greater than a whole. That is because our whole has how many parts? 7. We have how many? 9. There are 7 in one whole. We have enough to make one whole with 2 others. Changing it to that mixed number. I know you can do it, so I'm going to push you to do things a little bit more. Okay, let's look at the next example. Our next example is 3/4 plus 7/8. Well, let's go over to our fraction tiles. Now I gotta remind myself. 3/4 plus 7/8. Man, I picked some big fractions here. 3/4 plus 7/8. When you add fractions, the denominators need to be the same. I'm looking at the denominators, 4 and 8. I do not have that green light. I need to slow down, I need to stop, and I need to fix this so that they are the same. I'm going to find that common denominator. I'm going to show you if I got my 3/4 out. 1/4, 2/4, 3/4, and then we have 7/8. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. 2, 3, 4, 5, 6, 7. We can see that this is not showing us the sum of when we put them together because we're still looking at those two different size pieces. I'm going to find a common denominator. So when we find that common denominator, we are looking for what multiple of the denominators can we have that would be the same. So this is an example where we might not have to change, and if we go here, and it says, do you need to change one denominator, both denominators, or neither? Remember in our first example, we needed to change that neither because they were already the same. When I come here, I'm going to start thinking, oh, what are the multiples of 4 and what are the multiples of 8? And do they have any that are the same? I'm going to come here so I have a little bit more room. Let's start with the multiples of 4. 4 times 1 is 4. 4 times 2 is 8. Oh, well, when I say the multiple of 4, I notice that 8 is already a multiple of 4. So 8 is something that I can change 4 in, or I can find an equivalent fraction. I shouldn't say change, but I can change, make 4s into 8s. These are already 8s. So if I can change 4s into 8s and these are already 8s, I only need to find an equivalent fraction of 3/4 so that this denominator will be an 8. We're going to review. Now that we've found our common denominator, we're going to take a second to review how to find equivalent fractions. So I am finding an equivalent fraction. I am not changing the value of 3/4, but rather looking at it with the different size pieces of 8ths so they match this one over here. 4 was a multiple of 8 because every 4th would be multiplied by 2 to give us 8ths. If our denominator was getting multiplied by 2, that means the numerators would also be happening at the same thing. 3 times 2 is 6. So now I have only changed the one denominator to 8ths, and I have the equivalent fraction of 6/8. So I'm going to go over to my recording sheet, maybe when I figure out how to do this. I'm still learning. And it says, if the denominator was changed, what would, To add the following fractions, do you need to change one, both, or neither of the denominators? I'm sorry, you all. And why? First thing I'm going to do is I'm going to say, I only needed to change one. And then why? Why did I only need to change one? Let's see if I can. This is funky, y'all. To solve the problem, I needed to change one denominator. I know this because 4, 8 is a multiple of 4. So since the other denominator is a multiple of the other denominator, we only need to change one. And if the denominator was changed, what would the common denominator be? The common denominator is going to be 8. And then let's go back to our fraction strips and let's show some of this work. So remember, these 4s are getting changed into 8s. Does anyone remember how they were changed into 8s? Or find that equivalent fraction? We know that to find that equivalent fraction, every 4th is equivalent to 2 8ths. So I will show you that here, but I'm going to get my 8ths and I'm going to say 1/8, 2 8ths. You can see that those 2 8ths are equivalent to that 1/4. But I didn't just have 1/4, I had 3 of them. So I needed 2. I'm going to need 2 more. That would be 4. And 2 more. That would be 6. 3 groups of 2 would make 6. Now, this is where our original problem was 4s and 8s. This is 6 8ths. 3 4s is equivalent to that 6 8ths. Plus the 7 8ths we already had. Numerator, or the denominators are the same. These are all 8ths, so the 8ths will stay the same. 6 plus 7 is 13, so I have 13 8ths. Stop. 13 8ths. It is greater than a whole. There's 8 pieces in the whole. We have more than those 8. Let's see. Let's get out our whole. 8ths. How many 8ths make a whole? Oh, 8 8ths. There's our one whole. And after the one whole, we have 1, 2, 3, 4, 5 8ths. I do want us to go back to our original one and show some of that work. So when we show that, we are going to show that we changed 3 4ths into 6 8ths. And then I would rewrite it as 6 8ths plus 7 8ths equals 13 8ths. Oh, I'm sorry, you all. This is not super organized. 1 and 5 8ths. So for this one, we changed one denominator just so that the denominators would be the same. Remember, denominators are the same. Green light. Denominators stay the same. Add the numerators and then see if it is greater than one whole. Now that we've looked at 2 examples, let's go back and think or look at what we've done so far. In our first example, we did not have to change either of the denominators. These denominators were already the same. They could stay the same. 7ths plus 7ths, denominators stay the same. Add the numerators. In our second example, we had different denominators. We had to stop, change one of them to find that common denominator. We only had to change one because 4 has a multiple of 8. we can find an equivalent fraction of fourths into eighths. So we changed them both into eighths. Well, we didn't change them both. We only had to change one. And when we changed one, they were both changed into eighths. So we didn't change any. We changed one. I think you might know what the next example will be. But let's look at it first. 2/3 plus 1/2. First question we're going to ask. Do we need to change a denominator? Can we add them as they are? Are the denominators the same? Do we have that green light? 3 and 2, we do not have a green light. We need to stop. We need to make sure these denominators are the same. We find that common denominator before we go ahead and add them. Now, remember, common denominator is by looking at what denominator or what size pieces can we find that are equivalent to the existing denominators. So let's look at the first one, 2/3. If I have thirds, I know 3 times 1 is 3. If we take those thirds and we partition them into 2 smaller pieces, they would make pieces of 6 because 3 times 2 is 6. If we partition them into 3 equal parts, 3 times 3 is 9. I am sorry. I'm going to back up, you all. I'm so sorry. I'll get to that real quick. My apologies. Do we need to change one, or can we only change one? Well, if I count by threes, will I ever skip count and say 2, 3, 6, 9, 12, 15? No. If I skip count by twos, will I ever say 3, 2, 4, 6, 8? No. So neither of these are a multiple of the other one. So that's where we have to look at the multiples of both of them to find a multiple that is the same. So I'm sorry. I hope I did not confuse you all too much. So let's look at the multiples of 3. 3, 6, 9. I'm going to stop because remember, I know my multiples and I know that multiples of 2 are always even numbers. And since I see this even number, I'm going to think, oh, 6 is even. That's going to be a multiple of 2. 2, 4, 6. 6 is the common multiple, so it is going to be the common denominator. For this one, we have to find an equivalent fraction for 2/3 and an equivalent fraction for 1/2. Let's go to our recording sheet so that we can get through the process together. It says to add the fractions, do you need to change one, both, or neither? Well, we know that we're going to change both for this. Let's see. Let's highlight this. I'm going to try to keep working smart. So we're going to change both. Why am I going to change both? To solve this problem, I need to change both denominators. And this is where I was very confusing, so I'm going to restate it. I know this because 3 is not a multiple of 2, and 2 is not a multiple of 3. Remember, you cannot multiply by anything 3 times anything to equal 2, and 2 times anything will not equal 3. So they are not each other's common multiple. So you are going to have to change them both to find that common multiple and that common denominator. We know that the common denominator of both of these is 6. I've already shown that, and it's hard to kind of save my work on here. So let's find those equivalent fractions. 2/3, and I want those pieces to be 6. I'm also going to find an equivalent fraction for 1/2 equals how many 6? Now, I am hopeful that we are looking at what we know about equivalent fractions and reasoning about this one. So 1/2 Well, what is half of 6? Half of 6 is 3. Those are things we need to start reasoning and piecing together. You can use that other strategy of finding common denominator or equivalent fractions that I'm going to show over here. But I want you to really know your halves, and that is something we have talked about. So let's go back to 3. How would you change those thirds into 6? Well, let's try it a different way this way. Let's show it visually. I have a third, and I want them to be 6. Well, it's going to take 2 6 or a group of 2 to find that equivalent. And that is because we are partitioning that third into 2 smaller size pieces. Oh man, I lost it again. Okay, so 2 thirds is equivalent to how many 6? Well, we know that 1 third needs 2 pieces or 2 parts to make the 6, but we didn't just have 1 third, we had 2, so they're each going to get 2. 2 times 2 makes 4. I'm going to rewrite that my 1/2 was equal to 3 6. Now I have equivalent fractions to the same value, but the denominators are the same. So if you were to rewrite this problem, it would be 4 6 plus 3 6. The denominators are the same. The denominators are going to stay the same. 4 plus 3 equals 7. Oh no, 7 6, more than one whole. How many pieces are in this whole? 6. And that would leave 1 6 more. 1 and 1 6. 1 whole and 1 6 of another whole. Remember, Miss G ate 4 6 of the pizza on Monday, 3 6 of a pizza on Tuesday. So I ate 7 6 of a pizza. I ate 1 whole pizza and another slice of another pizza. So think about what those mixed numbers mean. Okay. We explained why. We're going to come down here. Our common denominator was 6, and I showed you that previous work on the other slide. I hope you are still sticking with me. I'm trying my best. I know you are trying your best. It is now time for you to practice on your own /journal work. I hope that you are starting to see that I kind of try to set this up in some journaling task where we are going to actually do some writing and explain our thinking and our reasoning, because that is just as important as doing the work, but understanding why we do the work. Today, I am going to ask you to do a few problems on your own. I'm going to explain your work right now, and then we can move on. Your first problem says, and I need to change these. These look very similar to what we did. It says, I need you to tell me to add the fractions. Do you need to change one, both, or neither? You're going to tell me what you need to do, and you got to tell me why. Did you change the denominator? Yes, no, and why? It needs to be written out. If the denominator was changed, what would be the common denominator? Tell me. And then, does not say it, but I need you to find the sum. Go ahead and find that solution. There is 1, 2, and 3 different problems. They are set up exactly the same structure that the work we did together was. You can go back and watch this video as many times as you need to. Today, I'm going to ask you to do some additional practice. That is only 3 problems. So we're going to do some review back, additional practice. What do you know about multiplication and multi-digit numbers? Here are 2 problems. Do you use the area model? Do you use partial product? What is your go-to strategy? Show me the work. Okay? Remember, we are pretending all of the calculators went out in the entire world. We have to be our own calculators. We have to show our work. Last, I have had so much joy by seeing people play Salute or getting comments about people playing Salute with their families. I know that this has been so much fun for me to watch in class. But I'm going to show or put on the screen or share these with everyone on Dojo a different way to play. The way we play is completely fine. It's the way I've showed you. It's the way I think it makes sense for us. But let's say you have more family members or people in your house, or you might have extra friends over and you want to play with 3 people, I'm going to give you an option to play in a different way. We're still playing to multiply, we're still talking about our math, but this gives an opportunity to give a little bit more, or it gives us a chance to play with more people. Keep working on it. Keep thinking of what your product is. How do you know your project? Thinking multiplication, using your division. Start with the factors that you know. Continue to move up. And I know you can do it. I hope and hope and hope that I see you all so soon in person. I miss you so much. I am also going to post this video along with an additional one with someone else explaining the same thing I did today, because sometimes other people can explain it better, or listening to 2 people is going to make more sense to you. Please let me know if you have any questions. I'm asking you to try your best. I'm asking you to give a good effort. We can get through this together. I know you can do it. Have a great day, and I will see you so soon. Bye.